Tonight, since I'm a planetary scientist, we'll be talking about things mostly in the solar system, but definitely planets, and you'll understand that last comment toward the end. So let's get started. So I'm a Mars scientist, and as those of you who are regulars know, I always start off with an update on the two rovers that are currently active at Mars. And that's the Opportunity rover and the Curiosity rover. So today is Solar Day, or Sol 4651 for Opportunity. And just to remind you, it was actually designed for 90 sols, so it's far exceeded its warranty. Just to get the lay of the land, Opportunity landed up in a small crater, certainly smaller than the size of this auditorium. And over the last 13 years now, it's been driving along the surface of Mars. And right now it's on the western rim of Endeavour crater. And Endeavour is about 20-kilometer diameter impact crater. And a closer up view of where they are right now, and you're going to have a hard time seeing this, so I'll blow it up in a second. There's actually some squiggly lines in here. This is the rim of Endeavour. The crater is in here. The plains of Meridiani, where they landed, are out there. And I'll zoom in right here so you can see the current position. And so each dot is where they stopped for a day. And right now they're right here on the edge of the rim, and they're actually, let me back up a second, they're heading down here. This is about 1 kilometer away from where they currently are, and there's what appears to be a stream bed cutting into the crater right here. And they've decided to actually get out here in the smooth area where they can make better time, and then cut back into the crater rim. So this, let's see, what did I do? There we go. So here they're just ready to escape onto the plains again, and it should be another month or so before they get to the location that they're interested in right now. And just a couple of recent images. This is the crater rim that they're on. There's the interior of Endeavour crater, and here you can see tire tracks left behind by the rover. And this was taken about 10 days ago. Again, the rim of the crater, lots of very nice layered rocks, and they're seeing lots of clay minerals, which would indicate that these rocks actually have been in contact with liquid water, and they've been broken down into clays. So this is the summary of the mission so far. Again, it's day 4651. They've driven a little over 44 kilometers. The mission goal was 600 meters, so 0.6 kilometers. And they returned 217,000 odd images. They were hoping for at least 1,000. So by any measure, they're doing quite well. So let's move to the other side of the planet. The Curiosity rover has been on Mars since August of 2012, so 4.5 years or so. And it's now day 1618 for Curiosity. And this is where it landed. This is called Gale Crater. It's about 160 kilometer diameter impact crater. What's really exciting about it is it's got these channels that run into the crater, but in the center of the crater, there's this feature called Mount Sharp, which is about a 5 kilometer high mound of layered sedimentary rocks. And so the target landing site was here. They landed right in the middle of that ellipse. And for the last 4.5 years, they've been trying to skirt these dark sand dunes to where they can start climbing the foothills of Mount Sharp. And so here's a view from the surface of Mount Sharp. You see all these wonderful layers, which that gives geologists heart palpitations to see things like that, because it means, first of all, there was some periodic process that laid these rocks down, and the wisdom is that at the bottom of the stack, that's the oldest material. As you move up, you get younger and younger. And so they've got instruments on board that allow them to not only measure the composition of the rocks, but to determine what the environment was like when the rocks were formed. And so by starting at the bottom, they get a history of how the conditions on Mars have changed in this location over the last probably several billion years. And so that's what they're endeavoring to do. And this is just an overhead view. Here was the landing site. Mount Sharp is down here. And this dark material is very thick, dark sand dunes. It's eroded lava flows, eroded basalts. And they couldn't, or they rather wouldn't, cut directly across those to get into the mountains. The thinking being that if you tried that, you'd likely get stuck. And so they've spent the last several years just skirting the outside of these dunes. Right now, they're sitting about right here, and they're ready to break through the dunes and get on with the rest of the mission. And so this is a closer up view of where they're sitting right now. This was 1 day ago. This dark stuff is the sand dunes of Bagnold Dunes. And there's this knob here, or a mesa, a hill, that we'll look at in just a second. And so this is what that hill looked like from the surface. This is a telephoto lens view from the rover, taken about 2 weeks ago. And this is just a nice view. It shows how dusty it is on Mars right now. This is looking at Mount Sharp, or at those foothills, and you can see how hazy it is, and that's just this very fine Martian dust suspended in the atmosphere. So a couple of other things here. They have a set of magnets on board the rover, and they're on the front of the rover. So this is vertical, and they're designed to pluck magnetic minerals out of the dust clouds. And each magnet has a somewhat different strength, and so by looking at all the material that has gathered around these various magnets, they can get an estimate of what the material likely is made of. And it turns out it's magnetite, which is just an iron mineral that is magnetic. This was taken just in the last week, and this is the type of rock they've been seeing a lot of, and we've discussed this in the past, but for those of you that weren't here before, these bright lines are made of gypsum, so the same stuff that we make drywall out of. And gypsum is a calcium sulfate material, and the idea is these rocks were formed first, and they're layered, so whatever the process was, lake bed sediments likely, those rocks were formed, and then subsequently they cracked, and water flowed up, groundwater flowed up through these cracks, and the dissolved materials in the groundwater precipitated in those cracks, and what we have left behind is gypsum. And so that's another piece of evidence that this was a very wet environment in the past. And so here's just a couple weeks ago as well, looking at the Bagnold Dunes. And this is the rim of the crater off in the distance, but here's these dark sand dunes. And what they've been doing is sort of dipping their toes in the dunes. They drive across the edge of them and disturb, this is a tire track, disturb the material, and then they pick up a sample, look at the composition, look at the grain sizes, things like that, and then we understand dune forms on the Earth, and so this gives us a handle on the processes on Mars, how the material is broken down, how easy it would be to move under Martian winds, and things like that. And the composition definitely turns out to be basaltic sand, which is what we would expect. Okay, so you may sort of, at least I do, when I'm trying to get to sleep at night, think, boy, it would really be cool to be standing on Mars and see this rover go driving by. And so there's a CGI artist who has taken the actual images from Curiosity and mapped out the path of the rover, and he's inserted the digital rover, just to give you an idea of these various images, what this would look like. This is sped up by about a factor of 40. It doesn't go zooming by that fast. You'd have plenty of time to move if you were in the way. Okay, well, you get the idea. It's a very very nice little video. We'll do one more pass here and then move on. Alrighty. So here's the recap for Curiosity. Again, it's day 16, 18. They've driven about 15.5 kilometers, but returned, approaching 400,000 images. And the image quantity is partly determined by how many cameras are on board. There's actually 17 separate cameras distributed around the spacecraft. There's hazard cameras and navigation cameras and high-resolution color imagers and descent imagers, microscope imager. So if you are interested, just Google Mars Curiosity, find the website, and every day they post all of the images from all of the different cameras that are as they're returned to the Earth, and it's sort of fun to just look over the shoulder of the rover and see what it's been up to.